Hi guys, welcome to my second video. Today I'm going to talk about graphical representation of trigonometric functions and their attributes. I'm doing this video because my next video is going to be on Fourier series, and this video contains trigonometric functions and their areas and integrals, which is a prerequisite for understanding the concept of Fourier series. Okay, so first let us look at the sin x curve. That is just the regular sinusoidal curve which has a period 2 pi, frequency is 1 by 2 pi. We always know frequency is inverse of period, and amplitude, that is the distance from the mean to the peak or trough, is 1. So if we look at here, we can see that the area, if we integral from 0 to pi, we get this area. If we integral from pi to 2 pi, we get this area, which is of equal magnitude but negative of this. So if we integrate from 0 to 2 pi, the duration will be a period, and the result of the integration will be 0, because we will be getting this area plus this area. But this is a positive area and this is an equal and oppositely negative area. So these two areas will be cancelled away and the result will be 0. So one thing to note here is that whenever the length between the two limits of the sin x integral is equal to its period or any multiple of its period, the result is 0. Now let us look at the trigonometric equation. Y equals to sin x equals to sin minus x, and that is equals to sin x plus pi. So you will see in a minute that why these three expressions are equal, because when y equals to minus sin x, when we are inverting the sign of the whole function, that is sin x, the curve is reflected about the x-axis. So basically what we know is the sin x curve is like this, and this is reflecting about the x-axis, and so the peak goes to trough, and the trough here later goes to peak. And in this case, sin minus x, when y is equal to sin minus x, it is basically reflecting about the y-axis. So that is exactly what is happening, that if we hold a mirror about the y-axis, exactly what we see is happening over here. So in this case, the reflection about the y-axis and the reflection about the x-axis both yield to the same shape, and this is the shape that we're seeing here. So it doesn't happen in the case of all the trigonometric identities. They're different, and for sin x plus pi is for x plus pi, the curve is being shifted to the left by pi. So the curve starts, usually the sin x curve starts from here and it shifts to the left by pi. That means it's starting from minus pi and end up with the same shape. So for sine curve, y equals to minus sin x is equal to sin minus x, and that is equal to sin x plus pi. So the thing to note here is the whole thing is a reflection of sin x above the x-axis. So shifts, just now we talked about the shift, that our previous curve, it was shifting left by pi. So how do we know like where the graph is going to shift, the right, left, up or down? So here's a general formula. We can see that y equals to a sine bx plus c plus d. Here the constant that is being multiplied to the function sine a, that is the amplitude of the curve. Here the amplitude is a, and the period is 2 pi by b. So 2 pi by b, b is the coefficient of x, and the phase shift is basically the horizontal shift, whether the graph is shifting right or left. So the phase shift here will be minus c by b, and if this phase shift is negative, minus c by b, the curve is shifting left, and if this phase shift here minus c by b is positive, the curve is shifting right. So then the vertical shift is d. The vertical shift is whether the curve is moving upward or downward, and t is the constant that is being added to the whole function. So this vertical shift is a shift along the y-axis, and the phase shift or horizontal shift is a shift around the x-axis. So we will do some example of this type, and this thing will be clear later on. Now let us add a constant to the function and consider the equation y equals to sin x plus 1. Here a equals to 1, b equals to 1, c equals to 0, and d equals to 1. So d is the only value here that is going to have a contribution towards the shift of the curve. And since it is d, we will note that the curve is shifting upwards. So the period of the curve is unchanged, it's 2 pi. The frequency is 1 by 2 pi. The amplitude here is 1. Even though the curve is shifting upwards and the peak is at 2, but remember the amplitude is the distance of the peak or the trough from the mean position of the curve, and the mean position of the curve is at 1 right now because the curve has shifted upwards by 1. So still the amplitude is 1 because the distance from the mean position to the peak is 1, and the vertical shift is 1 since d equals to 1. So the thing to note here is that the graph is shifted upwards by 1 unit. Now let's multiply the function by a constant. So what we get is a equals to 2. This is the value of a, and b equals to 1, c equals to 0, d equals to 0. So a here is going to have an effect on the shape of the graph. So 2 sin x, we know that the period is 2 pi, still the frequency is 1 by 2 pi, the amplitude is 2 here because a is 2, and just to note that no constant added to x or the sine function, hence there is no shift. Since c and d both are 0, as a result there is no shift. Now let us have an integer coefficient of x and consider the equation y equals to sin twice x. Here we can see a equals to 1, b equals to 2, that is the coefficient of x, and c and d both are 0 as before. So now because of the b, the period is being affected, and we know the period is 2 pi by b, so usually the period is 2 pi, and 2 pi by 2 equals to pi. Now the period is pi and the frequency is 1 by pi, the inverse of period, and the amplitude is a, that is 1. So the thing to note is the period is halved and the frequency is doubled. So we have to know whenever a period is increased by a factor, the frequency is decreased by the same factor, and whenever the period is decreased by a factor, the frequency is increased by the same factor. This is because period is inversely proportional to frequency and vice versa. So now let's consider all the changes in one function, that is y equals to 2 sin 3x plus pi plus 1. Here a equals to 2, b equals to 3, c equals to pi, and d equals to 1. So we can see the amplitude is a, that is 2, and the period is 2 pi by b, that is 2 pi by 3, and the phase shift is minus c by b, that is minus pi by 3. The value of c is pi and the value of b is 3, and this is minus, so the curve is going to be shifting left, and it is going to start earlier, that is from here. And if there was no upward shift, the curve would be starting from minus pi by 3, but since there is an upward shift by 1, the curve is starting slightly before that. And the vertical shift is d equals to 1, so the curve is shifting upward by 1. Here we see the amplitude is 2, so since the curve is shifting by 1, and now the peak is at 3, 2 plus 1, 3, and the trough is at minus 1. So the thing to note here is that the graph is shifted upwards by 1 unit and to the left by pi by 3. y equals to sine 2x times sine 5x. So guys, these are the kinds of function, these are the reasons why I'm basically making this video, because you will be needing these functions in Fourier series. You might have to integrate this function in Fourier series and find the result. So first thing first, whenever you integrate this function from 0 to 2 pi, the answer is always 0. Why so? Now let's take a look at the graph. This graph is starting from 0, and here is pi by 2, here is pi, here is 3 pi by 2, here is 2 pi. So at 2 pi the pattern ends, and from 2 pi the pattern begins again. The same pattern is being repeated, so the period of this graph is 2 pi. And whenever there are two different terms like sine 2x and sine 5x, you are multiplying them from 0 to 2 pi, the length of the limit is equal to the period or any multiple of period. The integration will be equal to 0, because as we can see that these two peaks are being cancelled by these two troughs, these two areas, and these two areas will be cancelled by these two areas, these two areas will be cancelled by these two areas, so the result will be 0. Now this is another case, that is sine 3x times sine 3x. These are two identical terms, and remember, when you are multiplying two identical terms, no part of the graph is below the x-axis, hence there is no negative area, and no matter whether we are using the limit from 0 to 2 pi or whatever the limit we are using, the integration is not going to be 0 here. So because the area is not going to be cancelled out. And we can also see here that sine 3x times sine 3x is basically sine square 3x, and square of anything cannot be negative. So for two identical terms, the area does not become to 0. Now here are some of the examples that leads to 0 and that does not lead to 0. So sine 2x, sine 5x, two different terms, 0 to 2 pi. The length is 2 pi. That means the length is equal, the length of the limits is equal to the period. So the length is equal to period or any multiple of period, the answer will be 0. It could be minus pi to pi, it could be 2 pi to 4 pi, it could be 4 pi to 8 pi, or 0 to 4 pi. The integration will be 0. So here is sine 8x cos 5x. The integration will be 0 because it is 0 to 2 pi. And these are some identical terms, sine 3x, 5x, 5x, but these terms will never be equal to 0 because these are identical terms and there is no area to cancel out the positive areas. So this is the thing. Now next video is going to be on Fourier series. If you find this video helpful, share and subscribe to my channel. Thank you.